Hi, in this video we're going to look at a price point elasticity. We're going to figure out how to calculate a price point elasticity using our normal elasticity of demand equation. And then we'll actually take a demand schedule and a demand equation and calculate a price elasticity point at one of these values. In a future video we'll look at the midpoint method and talk about how the midpoint method is actually slightly different. So let's first get to the price point elasticity and figure out why I have this written here, where that comes from. So if we take our elasticity of demand formula, we have the elasticity is equal to the percentage change in quantity over the percentage change in price. A percentage change is just a new value minus an old value over an old value. So I'm going to do that for both the price and the quantity. So what we have is new minus old over old, new minus old over old. Percentage change in quantity, percentage change in price. So we'll use delta to represent the change in quantity. So we're just interested in how quantity changes over a certain quantity and the change in price over a certain price. Remember, this is a price point elasticity, so we're interested in a particular point. We're dividing two fractions here, so what I want to do is I'm going to take that bottom fraction and flip it, take the inverse. So what we have is the change in quantity over quantity times P over the change in P. And I can switch these two at the bottom, and that gives us change in quantity over change in price times price over quantity. We use this formula to determine the price point elasticity because we know a relationship between quantity and price, and we have a particular point that we're interested in finding the elasticity of, price and quantity. So normally the P and the Q are okay, right? I can tell you the price and quantity. A lot of people kind of get a little scared when we talk about change in Q, change in P. If you're given a demand curve, however, you're already given that information by using the slope. The slope tells you how quantity changes when we change price by 1. So notice I have a demand schedule written out here. All I've done is I've taken price, plugged it in here. So I plug in 100 minus 10 is 90. 2 times 10 is 20. 100 minus 20 is 10. So notice that that's our relationship. The change in quantity as I change price by 1, for each price change of 1, quantity is falling by 10, 90, 80, 70, 60, 50. That negative 10 is our change in quantity over a change in price. We get that from our demand curve. We could calculate it from our demand schedule. So let's find the price elasticity at a single point. We're going to look at a price of, let's do $5. So at a price of $5 and a quantity of $50, let's determine the elasticity of demand. So elasticity is the change in quantity over change in price, which is negative 10, times price and quantity. Right, so that's the same as negative 10 over 1. So what we have is negative 50 over 50. So we have an elasticity of negative 1. Keep that in mind. I picked that number for a reason. We'll talk about how we can find that on a graph in just a second. So we know here at 5 it's negative 1. Let's pick one of these smaller numbers. Let's do it at a price of 2, which means we have a quantity of 80. The elasticity starts with minus 10, so this part hasn't changed. We still have that same negative 10 relationship here, times a price of 2 over a quantity of 80. So we have minus 20 over 80. We have minus 1/4. So I'll slide my head over a little bit. So we have minus 1/4. I'll reset so it's a little easier to see. So minus 1/4, that's an inelastic number. Right? We know that it's always negative, and this value is less than 1. So we would call this point an inelastic number. So I'll just write a U here by the 5 because we found that was a unit elastic. I'll write an I by 0.2 because we found that was inelastic. Let's look at 0.8. So at a price of $8 and a quantity of 20, we can calculate the elasticity. So I'll go a little quicker with this one, right? Because it's still following the same process. Minus 10, a price of 8 over 20. So we have 80 over 20. So we have minus 4. So what we have here is an elasticity of minus 4, or negative 4. That's greater than 1 in absolute value, right? Because we care about the absolute value of all these numbers. We would call that elastic. So I'm going to mark that as elastic. And so what you're starting to notice here is that we have a unit elastic point, we have some inelastic points, and we have an elastic point towards the bottom. So let's erase this in a second, and we'll look at elasticities on a graph and talk about how those are related. Again, in a future video, we'll look at midpoint method, but let's keep focusing in on price elasticity for now. So if I were to draw this demand curve, we'd have quantity on the x-axis and price on the y-axis. If I set the price to be $10, right, if I set a price at $10, I sell no units. So that's the highest price I can charge to where nobody is willing to purchase it. At a price of $0, I didn't put it on this table, but at a price of $0, I sell 100 units. So I have a simple straight line demand curve. We already talked about at a 0.5, we saw that an elasticity equal to 1. We also calculated at a point of $2 when I sold 80 units, had an elasticity less than 1. And at a point of $8, we had an elasticity that was greater than 1. We had an elastic region. That relationship is not a coincidence. This is actually common across all linear straight line demand curves. The point right in the middle of every line, as long as it's a straight line, will have an elasticity equal to 1. That's our unit elastic point or unitary elastic point. So notice that I could have found that by saying the price is 10, so that means at a price of 5, that's halfway through. Or at a price of 5, that's also a quantity of 50, halfway to 100. So it turns out that all of the points along the bottom are in the inelastic region. We start at 0, and we work our way up. Remember, because inelastic means less than 1. And as we move towards the midpoint, we get closer to unit elastic. As we move past 1, that becomes the elastic region. We'll use the same demand curve in a future video to look at how that relationship exists with revenue, but it's important to see just on a basic graph that the elastic region occurs at the top of a line, the inelastic region occurs in the lower portion of the line, and an elastic point occurs right in the middle. So take some time, check the elasticities of these other points. So we found them for these 3 points, but go through and find the elasticity for each one. You'll notice that, again, in the middle at 5, we had an elasticity of 1. You'll notice that your elasticity grows, it starts relatively low and grows towards 1, and then at 1, it starts to increase past 1 and becomes more elastic. So take some time and work through that. If you're willing, post that in a discussion board so we can check the work and make sure that we're on the right page. Let's move now into looking at the midpoint method and why that might be preferable compared to the price point elasticity.